With the release of the paper and its few followers, an ongoing discussion has been ignited. There are scientists that claim that all or most quantum mechanical observations or quantum ontology can be represented by real numbers.
But first we will discuss the delayed choice quantum erasure experiment, because the multiple fallacies that reside behind the interpretations of this experiment is responsible for the public being in an incongruent state relative to quantum theory.
With every scientific claim I make, I am careful with my words. I do not wish to convey any apathy, to relay some type of aversion to the mainstream. Rather, I seek to unify, but sometimes I feel as though I am walking on eggshells. And to be honest, I am sick of feeling like that. When it comes to topics like this, that are gaining traction in the mainstream, it just gets me going, you know? And I have to bite my tongue. But I'm not going to bite it so much right now, because I'm here to tell you, they are wrong. And I will prove it.
The delayed choice quantum erasure, the experiment where multiple fallacies arise from its interpretation, whether for retrocausality or against it.
In the delayed choice quantum erasure, enigmatic phenomena arises not because of the dynamics of the experiment, but purely on the interpretation of the results. There is often more than one path to the right answer, but in the context of quantum ontology, there is only one solution which fulfills the necessary criteria, and thus explanations in academic papers, YouTube videos, etc. They are riddled with fallacies. In the canonical setup, Kim's experiment in '99, one often points to the post-selection bias, which manifests in the subsets of D1 and D2, the no-path information paths, as interference patterns, which on the surface appears that a retrocausal effect has been realized, until one simply adds the distribution patterns as if they were a jigsaw puzzle. This savage handling of vector mathematics and the effort to show that no interference patterns exist and a clump pattern distribution resides until post-selection bias overlooks a crucial detail. Notice that the extracted value is intensity, which is a scalar. If one simply bothered to look at the pi shift between detectors 1 and 2, one would deduce that the anti-parallel rotation constitutes a phase difference e to the I pi, or simpler still, cosine of pi shift. This equals -1. And thus, how could one extract a clump distribution? Surely the addition of a negative element would result in a sharper interference distribution. Or one could simply unrotate the pi shift, and now such shifts are gone, leaving a very obvious diffraction distribution. I cannot overemphasize the urgency of these errors. These mistakes are everywhere. But for the sake of visualization, let's assume the phenomena happens in the narrative. The motivation for doing so requires real-world examples to convey the urgency of the matter. Researchers have even argued that without the bottom portion of Kim's apparatus, no such interference patterns could be extracted. They even go far as to say that it is the changes in polarities and the potential arrival of D1 and D2, changes that happen in time, that are the cause for interference. This sounds like a retrocausal argument, whether it is for or against. It still contains the enigma. Notice how the narrative focuses on cause and effect, and how effect precedes cause. And notice how the narrative controls the cause stimulus in the first place. Let me explain. Let's go back to our experiment. We take Wheeler's delayed choice, a simple setup, and we alter this, and hence adjust the narrative. We use pre-programmed trigger values instead of random number generators. So what we are trying to show, or attempting to, is the linear chain of events that contain a different causality structure from the original. The values, of course, are chosen way before the setup, so that they are causally disconnected. Of course, no difference in the physics will manifest, and thus we are free to say that we are subject to some strange mechanics, with philosophical fallouts edging on free will or some other deterministic dynamic, which is of course unnecessary. This is what I mean. We just changed the narrative into some other strange territory, but the physics remain the same. No matter how the values are chosen, randomly, or pre-programmed, or predetermined, the physics does not change. So, there is only one simple explanation left. And this explanation does with selection rules. A basis representation from time initial that represents every scenario possible until time final. Nothing is retrocausal. No new basis changes or is added ad hoc. The basis representation changes, but the basis itself itself remains the same. Of course, at the time of measurement or collapse, some states will be deleted, but no new states will be added. Everything was included. These surviving states may be obscured, but it is our job to find them in the representation. That is just linear algebra. Unfortunately, there is not enough time to go into the subject of the true wave function, though this is the perfect place to stop. The true wave function will be covered in episode 0, part 2. Consider a Wheeler delayed choice setup. Oh, Jesus. That's terrible.
For the record, the geometry was fine.
Which consists
The geometry's fine.
of a square-like path to where a
I
photon
sound like a square.
whose wave function is split between path A and path B.
Oh man.
One along
You
each side
understand
of
why
the
this
square,
is so bad, right?
You don't sound like a square.
so that it starts in the diagonal and ends in the far diagonal. That's what a square would say.